Yes, yes, friend. Now we have learnt about Gauss theorem, which states that surface integral of electric field over a closed surface, which includes some volume inside it, zero, is equal to total charge inside divided by epsilon zero. Now, with the help of this, we will try to find out electric field due to different configuration of charge. So, first of all, it is here. I have not drawn diagram before because I want to discuss. The heading is electric field due to long linear charge. Long means infinitely long. Long means infinitely long. Maybe infinitely long. So what is the meaning of infinitely long? ये भी बहुत जरूरी समझना. Actually, it confuses the students who think their own way. Here, suppose it is a long line. Don't think it is a conducting road. But only on a line there is charge. This is long line. And we treat it infinite long. Why? Because point P is here. With respect to this point P, distance R. The length of line is very large. For example, if line length is 1.5 meter and distance of point P is 3 or 5 centimeter. So 4-5 centimeter length of 1.5 meter or 2 meter can be treated as infinitely long. I think it is clear to you now. Please see the diagram. This is the here charge distribution. Positive charge distributed over the infinite length. पूरा डायग्राम में थोड़ा धुंधला है. ये line has known as cylinder. I am making it little wider just for clarity. Here positive charge distributed over the line. You want to find out electric field at distance close to its point P here. With respect to distance R, the line is supposed to be infinitely long. Maybe infinitely long. So infinite, I have told you many times what is the meaning of small and large or long. When we say it is long, means infinitely long. Means it is bigger, much bigger than some given other quantity of same dimension. So here point P, distance R. Right? So we want to find out electric field. Then how to describe this charge? We describe this charge as lambda coulomb per meter. Means let charge be lambda coulomb per meter. Means on 1 meter length, a charge of lambda coulomb is present, and lambda here is equal to linear charge density. Linear charge density. Charge per length ऐसे आएगा surface charge density. Charge per area is called surface charge density. So to apply Gauss theorem here, we need a Gaussian surface, closed Gaussian, it should be closed. So we imagine here a cylinder of height which is much smaller than length of the cylinder. Let the side be h. Let the side be h and radius r. Because charge I have taken positive, so electric field at P due to this line is this way radially outward. And here this surface area, this is the curved surface cylinder. Here is the cylinder, suppose this is the curved surface, this is circular face. This face is called circular face. This is the cylinder here. This is called curved surface. Area element here will be normally outward, this way outward, here vertically upward, here vertically downward, because area element is always normal to surface and outward. I am looking here diagram little dim. Let me make it more clear. Although it should be dotted line. Cylinder here has height h and radius r. This is radius r and height h. So this has three faces. This curved cylinder has three. One curved surface, two the circular face, three this. The three surfaces are there. Let this be S1, S2, S3. The area element here we have direction this way, ds. But electric field again outward. At the surface element downward and area element or electric field this way. So electric field always away from the distribution. To find electric field, diagram you can see if you feel it is not readable. Actually, light problem is there some. If I make light, तो ये और चमका तो है, चमक जाएगा. So in figure, we have a long linear charge system having charge lambda coulomb per meter of the length of line. This line is finite long. Infinite long means it is very much larger than radius. To find electric field at point P here, we imagine this area element which is outward, and electric field at this point also radially outward. Here on surface has to ds vertically upward, electric field outward, and so on. So applying Gauss theorem, you can describe this thing. Let in figure we have a long linear charge distribution, having lambda coulomb charge per unit length, per meter of length, and lambda here equal linear charge density. To find electric field at P, we imagine closed Gaussian space, a cylinder of height h, radius r. Now applying Gauss theorem. Applying Gauss theorem to this. Gauss's theorem to this Gaussian surface. To this Gaussian surface, we get S1 E dot ds, S1 plus S2, क्लोज करना है इसको, E dot ds plus S3 E dot ds. Now see here, I have not put this sign here. Why? Because the surface will get closed when we find integral of these three terms. But if your teacher in your contact put this sign, you can put. But here, or you can write like this also. No problem. Now at surface S1, at surface S1, at surface S1, that is curved surface cylinder. Vector E parallel to E, ds sorry, at two circular faces, vector E perpendicular ds. Sorry, here the surface integral is equal to total charge inside surface. Total charge inside surface क्या होगा? Actually lambda coulomb charge is present on 1 meter and length of line inside cylinder is only h. So what is the charge on h meter length? H into lambda upon epsilon 0. Lambda coulomb per meter means 1 meter of length has lambda coulomb charge and length of the distribution inside cylinder only h. So we'll take the total charge inside the surface, not outside, which will be h into lambda. So here I written at surface S1, E parallel to S and S2 and S3 it is perpendicular. So equation 1 reduce to क्या भाई? It will reduce to integration S1 E ds cos 0 plus S2 E ds cos 90. ये cos आ गया, ये डॉट प्रोडक्ट है, डॉट प्रोडक्ट A dot B A B cos theta. Remember dot product plus S3 E ds cos 90 is equal to lambda h upon epsilon 0. Cos 0 1, cos 90 0. So these two terms become 0. So we can write S1 E ds. Plus 0 is equal to lambda h upon epsilon 0. Or because at every point electric magnitude same, so E constant come out S1 ds is equal to lambda h upon epsilon 0. Now integration ds means total surface curved, total curved surface and curved surface of cylinder. Total surface curved surface cylinder is 2 pi rs. So E into 2 pi rs equal to lambda h upon epsilon 0. H cancel, so we get E equal to lambda upon 2 pi epsilon 0 r. What is lambda here? Charge per length. While finding the electric field due to this numerically, lambda should be placed in coulomb per meter. Generally, coulomb is very big unit and linear charge dash may be given in 100 microcoulomb per meter. So microcoulomb converted to coulomb are given in centimeter comes in meter. Now one thing more. We know 1 upon 4 pi epsilon 0 direct. Do you remember? But you are not here, so it is 9 10 to the power 9. It is 1 upon 2 pi epsilon 0. So to make it simple for calculation purpose, we write E equal to 1 upon 4 pi epsilon 0 2 lambda upon r. So you can directly write this value 9 10 to the power 9. Generally I have seen students start writing value by 3.14 epsilon 0 8.85 and calculation become difficult. So this is here electric field due to magnitude of electric field. If you want to write in vector form, then write E equal to vector E equal to 1 upon 4 pi epsilon 0 2 lambda upon r and r cap, where r cap unit vector pointing away from linear charge distribution. Generally, people ask write in vector form, and vector form help a lot. Make it simple. So I think it is clear to you all. Electric field due to long linear charge distribution. So simply we write a lambda upon 2 pi epsilon 0 r. But for make it more simple, we write like this. If charge is negative, so it will minus lambda, so r remains same. Or minus sign will indicate that diagonal electric field is opposite to unit vector r. So this is something about application, one application of Gauss theorem, that is electric field due to long linear charge distribution. Thank you. Take care of, start writing, learn, write yourself 2 or 3 times, only then you will get it.